Alright, so this video is probably going to be a little longer because we have two levels of examples. We've got the really easy ones to remember what to do, and then we've got the ones that take longer. So remember, when you're adding or subtracting, you must have a common denominator. So remember, if you're adding and the denominators are the same, then it's easy. You get to just add numerators. So 7 plus 5 equals 12 over 2y. And then you ask yourself, hey, does that factor at all? Does 12 over 2y factor? And sure enough, 12 can divide by 2, and we can end up with 6. So we could say that's 6 over y. Okay? Remember, if you have subtract, I encourage you to change it to add the opposite right away before you forget that it was subtract. The denominators are the same. Yay! So I get to just add the numerators. So I have 3 minus 2 over r squared minus 4. To see if this simplifies, I need to actually factor this. Binomials have to be factored. So hopefully you recognize that as the difference of squares there. R plus 2, r minus 2, yay. So hey, the r minus 2's can cancel out. So we end up with a 1 holding down the numerator spot and an r plus 2 on the bottom. So not too bad if you have the same denominator, but what do we do if we don't have the same denominator? If it's subtract, change it to add the opposite right away before you forget. Then factor the denominators. Remember, the denominators are the bottom of the problem. We're going to collect all the factors needed to make the LCD and multiply the fractions by the part that they're missing and combine like terms in the numerator so that we can add those numerators. Alright, starting with an easy one. This one doesn't have much factoring because these aren't binomials. This is an m. This is a 4 times an m. So my common denominator is going to be the m that you need from this first factor, the 4 that we need for this fraction, and then when I look here, I'm like, I need an m. Oh wait, I already have an m. If the same factor is part of both fractions, you can reuse it. The only thing you can't do is reuse it twice for the same fraction. So the common denominator is going to be 4m. So when I come back to my math problem, I'm like, oh, great, this fraction already has both of those pieces. I don't need to change the second fraction. But this first fraction does not have a 4. So I need to give it a 4. Okay, so if I multiply by 4 on the bottom to make me have 4m, I also have to multiply by 4 on the top to get what I need. So now I'm going to multiply that numerator together. So I have 24 over 4m plus 3 over 4m. And now that I have the same denominators, I add the numerators. So 27 over 4m. And 27 and 4 do not have any common factors to simplify away, so that would be the end of the math problem. Alright, turn the page here. Something that's a binomial. Alright, so what's a subtract? So I'm going to change it to add the opposite right away. Then I'm going to see if my numerator or denominator factors. Nope. Does this one factor? Nope, already factored. So my common denominator needs to be every part of every denominator. So I need a y to make this denominator. So I'm going to need a y for my common denominator. And I need a binomial y plus 6. So I'm going to need a binomial y plus 6. Both fractions will need to have this before I can add them. So if I come back over here, I realize this one just has a y. So we'll have y plus 6 to multiply in. This one just has a y plus 6, so I'm going to multiply by y. Okay, and now I actually have to multiply my numerators together. So in this case, that's going to be y plus 6 times 2. So I should distribute the 2. So I'll get 2y plus 12 over y times y plus 6. That's how I prefer to look at it. Plus, here I'm going to have negative 1 times y, so I'll have negative 1y over y and y plus 6. So I'm going to add my numerators now because my denominators are the same. And then I'll see if anything can simplify. So let's see, 2y plus negative 1y. Those are like terms, so I put those together and I get 1y plus 12. So y plus 12. You don't have to have the 1, but if you do, you don't have to erase it. Remember, it's a binomial. So it either all stays or all goes. Parts of it can't leave. So since it's different than the y plus 6, it stays. And that's our final answer. Okay. All right, if you're feeling pretty good with that, you could fast forward for this example and get to this example. I'm going to do this for anybody that wants it, though. Again, this one is like the one before it. It's already factored. You can't do anything more with an x plus 3 or an x minus 7. I'm just going to need to put the x minus 7 over here because it's missing it. And I'm going to put the x plus 3 over here because it's missing. So I'm going to get both of my fractions to have x minus 7 and x plus 3 on the bottom. Okay, I'm going to be a little lazier this time, and I'm just going to write my fraction bar one time. I need to multiply these together, so this would be x squared minus 7x. And I'm going to add that to 2x plus 6. So if I add like terms, I'll get negative 5x there in the center. Okay? All right. Now hopefully you didn't tune out too long because we're going to move on to this example, which everyone should see. So tell a neighbor, tell a friend, watch it. This one subtracts, so we're going to change it to add the opposite. And before I can tell what I need to have on my denominators, I have to factor them. So I have to figure out what little Legos they're made up of. They are fortunately shortcut problems because a equals 1. So I can just think about what multiplies to negative 4 that adds to positive 3. That would be a positive 4 and a negative 1. And over here we have a and a. And the numbers that can multiply to 12 and add to 7 are a 3 and a 4. Okay, so for common denominator, I'm going to need one of these a plus 4s and one of these a minus 1s to make this first denominator. Over here, a plus 3, that's different, so I'm going to need one of those. And a plus 4, oh wait, I already have that. I don't need an extra one. So they both already have one of the Legos they need. We just have to make these ones match up. So this first fraction has the a plus 4, has the a minus 1. It's missing the a plus 3. So if you need to add it to the bottom, you also add it to the top so you can distribute it. This one has the a plus 3 and the a plus 4, but it's missing the a minus 1. So if I add it to the bottom, I add it to the top so I can distribute it. So I have negative a squared minus 3a, and then I have negative 4a squared plus 4a, all over the common denominator, which has an a plus 3 and an a plus 4 and an a minus 1 in any order in it. All right, so add like terms. negative a squared and negative 4a would make negative 5a squared, I believe. And negative 3a plus 4a, same as 4 minus 3, would be 1a, all over the common denominator. Now this does simplify on the numerator, so maybe there's a hope of something canceling out. I could remove a common factor of a, but nope, nothing's the same. So even though I can do that, I can't get anything to cancel out. So that will be my answer. Alrighty, you made it to the end. Give it a try.